Hey everyone! Today I'm going to be building a machine learning model for the big upcoming Valorant tournament in Berlin. We'll use the model not only to predict the overall results of the tourney, but also to see some cool insights about individual players. For those that haven't heard of Valorant before, it's a round-based tactical shooter game. There are 5 players on each team, and the goal is to win rounds, where round wins come from eliminating all the players on the other team, or by planning or defusing an objective called the spike. Each game is up to 13, win by 2. And the background gameplay you're watching right now is of the first international Valorant tournament in Iceland. If you're interested at all in either Valorant or machine learning, or just want to stick around for the good vibes, I hope you enjoyed the video. I'm going to first run through how I created the model. It should be mostly high level and followable for anyone who's interested in machine learning and is familiar with the basic general ML concepts, but there should also be a few sprinkles of details for you ML nerds too. For those uninterested in these model details, I take no offense, and feel free to skip to the results part later on in the video. The first step of the project was to get some data. I ended up deciding on building a web scraper to scrape stats from the website vlr.gg, which you can see on the screen here. The thing is, I have very little experience with web scraping. Yeah, you know that one meme with the 3 dragons? My web scraping skills would definitely be that right dragon. On second thought, yeah, this is probably more accurate. Nevertheless, with the unparalleled weapons of Google and Stack Overflow in hand, I said screw it, I got started with building a simple scraper to get the stats I wanted from vlr.gg. I'll mostly be coding in Python for this and future videos. For libraries, I ended up using the request library to get HTML and an HTML parsing library called lxml to parse that HTML. The first thing I wanted to do is get the stats for a particular game. I ended up deciding on the Sentinel's Rise game for no particular reason. I inspected the page to try to find the values I wanted to scrape, and then once I found them, it was just some not that difficult, but slightly tedious work to locate the particular values in the scraped HTML. I ended up writing a simple BFS helper to iterate through the HTML tree, and use some jank math to iterate over the table of stats. Once I got the scraping working for one game, all that was left was extending it to take an arbitrary URL, and then deciding how I wanted to store the scraped data. I ended up storing the data as text files of rows, of lists of numbers in an order that I expected, but yeah, I guess that's not optimal for production, but definitely good enough for me. So the final data I ended up getting for each map, so for each row in this dataset, were the rounds won by Team 1 and Team 2, the map, kills, deaths, assists, and ACS per player, and then the pairwise KDs. And by pairwise KD, I mean for each player on Team 1, how many kills and how many times were they killed by each player on Team 2. So the pairwise KDs could be represented by 50 values. I also augmented the data by both permuting the ordering of the teams and the ordering of the players within each team, as I didn't want the model using that information to make predictions. Now onto the more fun part for me, that was the actual modeling. So when I first thought of doing this project, I knew I definitely wanted to do something with player embeddings. For those of you who have heard of word embeddings in natural language processing, this would be analogous where a pro player corresponds to a word. If you're less familiar with embeddings, you can think about it as something along the lines of FIFA cards, where both the categories and the values for each category for each player would be learned from the data. So the goal would then be learning meaningful embeddings for players that kind of capture their play style or profile. So the first architecture that I came up with looked something like this. The input is the 10 players in the map. We then get the player embeddings and the map embeddings, concatenate them together, and then pass this representation into a basic neural network. And I hope this would capture interactions between the different players and the map. We then take the output of that and pass it into each of the 4 basic output layers, one to predict assists, one to predict ACS, one to predict pairwise KDs, and one to predict the rounds for each team. The first noticeable issue with this model was that it ended up making very uniform predictions. So for example, it would think every player on Team 1 would go 3-3 against every player on Team 2. To address this, I wanted to amplify the signal that differentiates the players. So in the first architecture, the input to the KDNet was only the output of the first neural network, which had already combined the info of the 10 players into one vector. And then the KDNet was supposed to look at that and generate all the pairwise KDs at once. I changed this to more directly model the pairwise nature of the KD data. The new KDNet directly takes in a Team 1 player embedding, a Team 2 player embedding, the map embedding, and the output of the first neural net, which can be considered as some sort of interaction signal for the rest of the players on the map. And then it outputs the predicted KD for the specific player matchup of the first two embeddings that it takes in. It does this for each of the 25 possible matchups from a player between a player from Team 1 and a player from Team 2. As I was iterating on the model and diving deeper into the data, I also had sort of a mindset shift on the goal of the model. Similar in vein to an ML model trying to complete a prompt in natural language processing, I thought I'd rather focus on having the model output interesting, realistic samples, rather than getting the so-and-so correct prediction. This made sense to me to do since there's just so much inherent variance in Valorant, especially when we consider that the only data we're working with for the final inference problem would be the players on each team in the map. Towards this goal shift, I decided to do more of a generative style modeling of the data. Now this part's a little more technical, so don't worry if you don't fully understand all the terms I'm using, but basically instead of having the model output direct predictions of the metrics I was interested in, I wanted the model to output parameters for the distributions that I asserted the metrics followed. Then I would be able to sample from these distributions at inference time. I'll list the distributions on the screen now for those interested, and here all the lambdas are outputs of parts of the model. The last main challenge I faced was regarding the quasi-independent assumptions I used during modeling and sampling. So for example, the adjustment in modeling each of the pairwise KDs separately, mentioned before, it definitely improved the learned embeddings, but it's a little unrealistic in the sense that in reality there are definitely correlations in the pairwise KDs both across players and across teams. I adjusted my architecture to help capture some of the easy correlations. So for example, I adjusted the KD network to depend on the map rounds output, because you'd expect different sorts of KDs in a 13-0 game compared to a 13-11 game. While the changes I made here definitely helped, this is the area I'd probably look the most into improving if I had more time. The architecture of the final model used to generate the prediction looks like this. So the model first gets the embeddings for each of the 10 players in the map and concatenates them, and then passes this representation into the rounds network, which outputs parameters which we use to sample the rounds won by Team 1 and Team 2. Then the model uses the embeddings as well as the number of rounds won by each team to generate the parameters for the distributions for assists and the pairwise KDs. We then use these parameters to sample the actual assists and pairwise KDs for the map, and then pass these values into the ACS network to get the ACS per player. You can see the training curves for each of the parts of the final model used to generate the results on the screen now. The last thing I wanted to talk about before moving on to the results is what I would want to improve if I were to do a V2 of this project. So I think V2 of this project will naturally come when we have play-by-play data for individual rounds. This means the model could be some sort of a sequence model, and simulating rounds sequentially would both help mitigate some of the independence issues I've been talking about and potentially capture other interesting factors like economy. And another thing that popped in my head was a GAN style approach, since I've been talking a lot about generating realistic samples. This is something I could try with the current data I have. I just ran out of time as I want to release this video before Berlin. Alright, that wraps up the modeling. Now let's move on to the results. Before we dive in, I just want to reiterate the goal of the model and how to interpret these results. The goal of the model is not to generate the most correct prediction. Rather, it's to generate realistic samples of instances that are relatively likely to occur. And I think this approach captures the variance inherent to Valorant. If the same two teams were to play the same map multiple times, you'd expect a wide variety of results, not the exact same result every single time. Additionally, if our goal was to target the most correct prediction, I would say the quality and quantity of data is probably on the lower side, especially for the international matchups. Nevertheless, I think there are definitely insights to take away from what the model was able to learn. Before training the model on all the teams and generating predictions for Berlin, I first did a test run on NA Challengers 3, where I trained the model only on NA games that took place before the event and predicted the result of the event. This allowed me to evaluate the model in a few ways. First, since I'm much more familiar with the NA pro scene than the entire world scene, I was able to more easily look at the player embeddings and see if they made sense. Second, I could evaluate the model predictions since we had the data for what really happened. Let's first take a look at the NA player embeddings. What you're looking at now is a 2D visualization of the player embeddings using an algorithm called t-SNE. While these points themselves are not actually the embeddings, points close in this visualization should correspond to player embeddings that are also actually similar to each other. When I saw this visualization, I was pumped, because it looks like to me the embeddings are capturing meaningful information. We see a lot of the aggressive duelist players in the upper left. It's also really cool to see is that the embeddings were able to group the jet mains like Wardell, Ye, tenz, Qualanoob, Dizzy Life, Penny, and others close to each other and further away from the Asuna, Shotup, Sean, and Victors of the world, who play more Raze and Reyna. And keep in mind, no agent info was given to the model. Towards the bottom, we see a lot of the Sova mains like Effys, Hiko, Crashies, BCJ, Zeta, Derek, Leviathan, and Gangsta. And then we have the smokes and sentinels largely scattered throughout the middle and right side. To me at least, it feels like the smokers and sentinels closer towards the duelists play more aggressive styles. So for example, like Marv, JC Stani, and a Proto. I'm not fully sure on this, so someone with more Valorant knowledge, please correct me if I'm wrong. But overall, I was really impressed with the embeddings produced by the model. I gathered the full set of model predictions for NA Challengers 3 into this Google Sheets, which I'll link in the description of the video. The first page is the overview page, which contains the bracket and the per game predictions. For each game, you can also click the match details link, which brings you to a page with a lot more detail and has the actual sampled output from the model. I'll walk through this first Sentinels Rise game, and then if you're interested in the details of any other game in particular, feel free to explore the sheets. On the upper left here, we have the model output for the first map, Breeze. The third row is the expected rounds the model thinks each team will get if they were to play this map many times. And the fourth row is the actual sampled result for the game. And that's what's used in the overview sheet. For the sampled result, we assume no OT and allow 13-12s, which just signals it's a really close game that probably would have gone to OT. Based on the sampled result, the model then further samples player stats. The first table has the overall map stats per player, and the second table has the pairwise KDs. Overall, I was fairly happy with the detailed samples. However, as mentioned before, there are definitely still quirks that sometimes appear where you could probably tell it's not from a real game. I think the games the model currently most struggles to create realistic samples for are very close games that go like 13-12 or 13-11, or complete blowouts that are like 13-0. I think for the close games, from what I've seen, the model usually underrepresents the number of kills and deaths that actually happen, and for the blowouts, usually the ACSs seem low. Another small kink is that sometimes players have a few more deaths than rounds played, which is mostly impossible. I also do want to say that these results here are slightly cherry-picked. For each game I sampled about 3 times and took the sample that looked best. Still, given the independence assumptions in the sampling procedure, pretty happy with how most of these detailed results look. On the right, we have the same metrics for what really happened to compare against. So yeah, looking at these results from the model, we have a really close Breeze game that Sentinels ekes out, then a comfortable Sentinels win on Ascent, and since we have the true games that happened, I ran the model on all the games, even if the match would have concluded. So yeah, the model also predicts Sentinels pulls out a comfortable victory on Bind. As an overview, yeah, it looks like the model sampled Sick had a great series here. Okay, back to the overview. For a quick summary, it looks like the model overvalues TSM, but most of the other expected rounds look pretty good. And unsurprisingly, the model believes Sentinels will win the tournament. Alright, let's move on to the Berlin results. Similar to NA, let's start with the player embeddings, but for all players in Berlin. In the top right, there's a cluster of most of the duelists, which is cool to see. Also not surprising to see Bunny a bit further away from the rest of the duelists since he has a pretty unique playstyle. Other interesting things, let's see, I know a lot of people are excited to see the Dapper Nats matchup. Looks like Dapper is the dot right next to the Shazam near the middle. So the embeddings for Nats and Dapper are actually quite different. I don't really know how Nats plays, so I can't say anything deeper, but if anyone has any ideas, definitely feel free to leave a comment. Yeah, I guess in general, less knowledgeable here on the international scene. So if anyone sees anything cool in the visualization, please feel free to leave a comment. And now for the tournament predictions. Actually, a few small notes before we go. For the maps selected for any game, I let the model randomly choose. I was considering using prior map info for teams, but ran into complications with Breeze being recently introduced and questions about if teams would ban their least played map or their opponent's most played map. Also, there are a few 5+ man rosters in the tourney, and for simplicity and since I'm running out of time, I just stuck with one particular version of the roster for the whole tourney. So apologies to fans of those teams whose rosters might not be fully accurate for certain maps. If I had more time, yeah, I would have liked to do a bit more research on both these areas to make the matchups a bit more realistic. Alright, we are ready to get into the Berlin predictions. On the right, I'll be showing the predictions made by the model, and on the left, I'll be filling in the bracket as we go, just so we can keep track of everything. I also have the overview page fully filled out in the sheets, but I don't want to reveal everything all at once. And yeah, if you want to pause at any time to look at the stats in detail, feel free to. But also, I'm going to link the Google Sheets in the description, so feel free to follow along if you would like. Sorry in advance if I butcher any names, and yeah, let's start with game A1. Here we have a convincing Vision Strikers win, not too surprising. For game A2, SMB takes a close map 1 off the performance of Russ, Ascend responded map 2 off nice games from CNET and Kyles, and SMB takes game 3 off of a great team performance to take the series 2-1. On to Group B. In game B1, we have a comfortable 2-0 win by Envy over Vivo Keyed. Victor has a great series here. In game B2, Zeta Division squeaks out of map 1 off nice performances from Laz and Crow. Crew responds in map 2 with a dominant win, and then Crew ekes out a very close map 3 with a solid performance from Delzik. In Group C, we have a relatively comfortable win from Gambit over Crazy Raccoon in game C1. Very surprisingly, Crazy Raccoon was actually slightly favored over Gambit on Haven. In game C2, 100 Thieves inches out a tight win over Havan Liberty in map 1, and then comfortably wins map 2 for the 2-0. Oh yeah, I forgot to mention I'll be simulating Group D if Bren could have gone, because why not? Unsurprisingly though, Sen has a comfortable 2-0 against Bren in game D1, and in game D2, we have G2 with another comfortable 2-0 over F4Q. Colloques especially has a nice series here. Okay, we're back to Group A. In the uppers, Vision Strikers has a dominant win over SMB map 1, and then a tight win on map 2 off of a nice performance from Stax. In the lowers, Forsaken has himself quite the series, but Paper Rex are not able to complete the upset. Ascend take a close 2-1. Moving on to Group B, Envy takes yet another comfortable 2-0 over Crew to advance, this time off the backs of Yay and Crashes. What a draw for Envy, am I right? In the lowers, Vivo Keyed takes a close 2 maps over Zeta with a really nice performance by Heat. In the Group C uppers, 100 Thieves has a dominant Game 1 performance led by Ethan. Gambit and Defo respond in map 2, but off the unlikely hero performance from Steel in Game 3, 100 Thieves takes the series 2-1. In the Group C lowers, Havan Liberty takes a tight 2-0 over Crazy Raccoon. In the Group D uppers, Sentinels has a surprisingly dominant 2-0 win over G2. Tenz absolutely pops off this game. In the Group D lowers, F4Q take a tight map 1 despite a great performance from Dubstep, and then win a comfortable map 2. Now onto the second place qualifying matches. In Group A, we have the SMB Ace rematch. Ascend takes this game 2-1 with a monster series from CNET. In Group B, we have Crew edging out a 2-1 series off of a great performance from Nags in Game 3. In Group C, Gambit win map 1 with everyone expecting them to go through, but Havan Liberty comes back with the reverse sweep for the first major upset of the tourney. Lastly, in Group D, G2 takes a very tight 2 games over F4Q with just a solid all-around team performance. I then redrew the knockout stage matchups and got the following bracket. Looks like EU got a rough draw here, but let's see if they can still pull through. In the first quarterfinal game, Vision Strikers wins a comfortable map 1 off fantastic performances from Lakia and Buzz, while Vova really struggles. Vision Strikers then takes a tight map 2 with another great performance from Buzz and knocks out G2. In the second quarterfinal game, Crew surprisingly takes map 1 from 100 Thieves with a great game from Klaus. However, 100 Thieves and their 100 years of LAN experience are able to reset and pull out tight maps 2 and 3 with great performances from the youngster Asuna. In the bottom half of the bracket, Envy takes a comfortable 2-0 win over Havon Liberty, with Victors and Crashies carrying game 1 and then Ye carrying game 2. And in the last quarterfinal game, Sentinels has a relatively comfortable 2-0 game, with Dapper completely shutting down CNED both games to knock out Ascend. The bracket now looks like this. Moving on to the semis, Vision Strikers wins map 1 with a great performance from King. 100 Thieves unsurprisingly bounces back, winning map 2, but unfortunately for them, they cannot complete their second comeback and fall in a map 3 to a great performance by Buzz. Surprisingly, Ethan has a very rough game 3. In the other semis, we have an NA vs NA matchup. Sentinels completely dominate map 1 with a great performance from tenz. Ye and Victor bounce back and help Envy take map 2. However, the tournament's favorites will not go down, and their IGL Shazam leads them to a map 3 win. So we have here the two teams that will vie for the championship are Vision Strikers, champions of Korea, and Sentinels, champions of North America. In the finals, maybe it's because Vision Strikers have showed everything leading up to this point, maybe it's just because they ran out of steam, but the reign of terror by Sentinels is evident in 2 dominant maps and 2 dominant performances by tenz, and Sentinels go up 2-0. Vision Strikers is able to win map 3 off the backs of Buzz and RB, but Sentinels slam the door shut in map 4 off of another dominant performance from tenz to win the series 3-1. And there you have it, everybody. Sentinels are your Masters 3 Berlin champions. If you enjoyed this video, I'd be super grateful if you showed it some love with some likes and subscribes. If you haven't clicked on my channel yet, you probably shouldn't, as this is literally the only video on it. And yeah, since I'm a complete noob at this YouTube thing, I'd love to hear any sort of feedback in the comments, whether it be something you'd like to see in a future video, something you would have changed about this video, or even if you're just an EU fan who wants to tell me how crappy my model is. I also plan on creating a Discord for the channel for quicker and easier interaction with viewers, and doing quick channel intro vids sometime. Those will be in the description or linked now whenever I end up getting to them. Feel free to check them out if you're interested, and once again, thanks for watching.